Hey developers, how's it going? In this video you will learn about recursion. What is the recursion, how it works, why we need recursion, and how to write recursion code, yes, and also what is the difference between iterative and recursive, and when you should use and when you shouldn't use recursion. And also at the end we will see some problems you will better understand about recursion also. And firstly, what is the recursion? The recursion is a way to solve problem by having function calling itself. And from this, for this, the one of the best example, that is the factorials. Yes, from maths, if you know, I hope you know, the factorials is a multiplication of the given positive integer, that are starts from the 1 and to the till the given numbers. And if I'm going to calculate the 4 factorials, I will write like this: the 4 factorials equal to 1 multiplied 2 and 3 and 4. Yes, this is the multiplication of the 4 factorials, yes, and then also from this 24 return it will give us. And from base this we will write the formula for our recursion, yes, and we will write the formula to the given n. Yes, if I'm going to calculate the n factorials, what I'm going to do from this, I will write the n factorials equal to 1 and 2, yes, 3, and goes to n minus 1 and multiply the n, yes. And if you see here, which is the, if you look at here, which is 1, 2, and 3, which is the 3 factorial, yes. And also I can write 4 minus 1 factorials. These are the same, which is the n minus 1 factorials. And from this, my formula looks like this: the functions takes our factorial functions takes the n and goes to n multiply the function calling itself, and we will give the n minus 1. And from this we created the formula to our recursion, yes. And based from this formula we will write the recursion code, yes. And we will write the recursion code, and our formula looks like fn equal to n, the functions inside n minus 1, yes. And for writing the code I'm going to use the Python, and we will define the function def and the factorials, and which takes the number, yes. And inside, firstly I must check the number that must be integer and positive, yes. If it is not, I will return easily error, yes. Therefore I will check the number that is assert the number must be greater or equal to 0, and number must be integer equal to n. If not, I will just return error. Must be error, yes. And after that line, the first line, this line is executed, it will not return error. If that line if not return error, I will go to the second line, which is the if condition. We will write here if condition, and that if condition, if our input is equal to 0 and 1, we know that our 0 factorials is equal to 1 and the 1 factorials is equal to 1. If our input inside the 0 or 1, if like so, we return and 1, yes. If not, else we go we return. We look at here our formula, that is n multiply n minus inside the function n minus 1, which is that we must call that function inside the function, yes. And firstly we will multiply n to the factorial function. We are just calling function and n minus 1. This is our recursion code, and you may be thinking about it. You may be asking, yeah, right now I can calculate that for a problem by using iterative, yes. And what is the difference between iterative and recursive, yes, and why we need it? You may be asking about it. Because yes, you can calculate it, and some problems it's very impossible to solve using the iterative, yes. And also some data structures like graph and trees we use recursion, and also we use some algorithms also we use in, for example, gradient, concur, and yes, divide, and dynamic programming we use much from recursion. and therefore we need recursion, and you must know about recursion also. And I hope you clearly understand also, if you can divide a problem into similar subproblem, you can use recursion. Whenever time complex matter in your code, don't use recursion, instead use iterative. Yes, and iterative much faster than recursion. Recursion, just advantage of recursion, just easy to write. Yes, you can just write and you can just solve complex problem. Yes, and then we can convert to the iterative one. Yes, if we can, and like so. The question may arise, why recursion is slow? Yes, the recursion and slower than iterative. Why? Yes, we will see how our function works. Firstly, from previous example, we have the factorial functions, yes, which is it takes number and it returns the factorials of that number. And then in this case, I will give the 4, and from here, and we will see how our recursion code it works. Yes, and whenever it starts execution time, yes, it goes to the 4 multiplied function. It calls itself factorials with the different and arguments, which is the 3, because 4 minus 1 is 3, and that factorials function goes to the 3 multiplied factorials, which is the different argument, which is 2, 3 minus 1, and that factorial function that goes to 2 multiplied factorials is 1. We know the 1 factorials is equal to 1, and from here our function returns the number is 1, and is multiplied by 2 and 1 or is 24, and the result is it will be 24. And this life cycle is represented on the memory like this. Our stack memory, you know the stack memory, that is LIFO, that is last in first out. And in our memory, our computer is the first store that factorials, the first function, yes, the factorials, the 4, it store here, yes, and then it stores that one also, the factorials, the 3 also, and store that one also, yes, and store also the last one also here. And whenever our last function is return 1, and it starts from execute, and for example, it starts removed from the last our function is returns 1, and that function is not longer on the memory. Yes, is removed by the computer. That one removed, and whenever it comes to here, that one removed. When it comes here, that one removed. When it comes the end of that, and that function also removed. And this situation takes time. Yes, from whenever for example, if I give the million number, yes, and for example 1,000, 100, 1 million, it takes a lot of time. Yes, therefore, and time complex is not as bad in the recursion. All right, it's time to solve some problem. I will better understand about the recursion by solving the problems. Yes, our problem is finding Fibonacci numbers. Fibonacci numbers starts from 0 and 1, and after that we will create the Fibonacci numbers, and for adding the 2 previous one. Yes, and for example, the third Fibonacci number is equal to sum of 2 previous, which is 0 plus 1 is 1, and after that, 1 plus 1 is 2, 1 plus 1 at 1 plus 2 is 3, and 2 plus 3 is 5, and that's 8, 13, like this. Yes, and if you the index of every Fibonacci numbers is a natural numbers. Yes, and for finding any given numbers, for finding Fibonacci of any given numbers, we just look at here. For example, and from 0, 1, yes, and 2, 3, 4, 5, 6, 8, and 7. For example, we must write a function which takes these numbers and returns the Fibonacci of that number. For example, if I give the 7 to my function, and then my function returns, it must return that 13. For example, if I give the 5, it must returns to me the 5. 6 must return the 8, and like this. Yes, and if you look at here, and the sequence of these numbers, which is the sum of 2 previous one. Yes, from this, what I'm going to do, I'm going to create a formula for any given n numbers for finding Fibonacci. Yes, we will write xn. Yes, xn equal to xn minus 1 plus xn minus 2. From this, I will convert the function and inside the function I will write the n, because we are taking a number to our function, yes. Therefore fn equal to fn minus 1 and plus fn minus 2, yes. This is our formula to our recursion code. Let's jump into Visual Studio Code and we'll write our recursion code there. First of all, I'm going to create a file which is recursion.py inside. And first of all, before writing our code, we must check our input to the integer and positive, yes. And our first line of inside our function, which is check condition. Let's will define a function and the fib, and we are taking number, yes, and inside we are checking our input is assert n must be greater or equal to 0, yes, and n must be integer. If not, we just return error, yes. And after that, if not, for example, our input is greater or than 0, yes, for example is 2 or 3, 1, we go to the next line. In the next line we will write our if condition, which is we are checking our input to 0 and 1. Whenever our input is 0 or 1, we just return that n itself, because you know our 0 Fibonacci and 1 Fibonacci is equal to itself, yes. Therefore, first of all, f inside 0 and 1 just return itself, return n, yes. If not and else, and we return our formula, which was we just called our function itself fib inside n minus 1, yes, and plus fib n minus 2. And this is our recursion code and for Fibonacci, yes, for calculating the Fibonacci. And we'll call our function and the fib. And well, first for the argument I'm going to give, for example, 4, yes. And we'll check, let's print it, and print and save it and open terminal, then write the Python and recursion.py, press enter, and it returns 3. And we know that our Fibonacci numbers and our 4 of Fibonacci numbers is equal to 3. If I give, for example, the 6, yes, it returns me 8, like this. We'll see on the whiteboard how our function is working. We have a function which is a Fibonacci functions, fib, and with the argument which we will give the 4. And whenever our function start to execute, yes, first of all we wrote the assert, yes, check condition to the input, which is the input must be integer and positive, yes. If it's okay, go to the second line, which is if condition, our input must be, if our input is equal to 1 or 0, it returns itself. Also, we just calculate and go to the formula f inside the function n minus 1 and n plus n minus 2. And whenever our function is right now on the argument is a 4, yes, our function goes to the fib, yes, call itself, and with argument 3 and plus, and the fib, yes, with 4 minus 2, which is the 2. And that function goes to again, which is n minus fib, n minus 3 minus 1 is 2, and plus, and the fib n minus 2, that is the 1, yes. And that function also goes, which is the fib, yes, with 1 and plus fib with 0. And we go there, and here this function returns the 0, this function returns the 1, and that function returns the 1 here, and this fib function returns the 1, yes. We know the 1 is whenever our input is equal to 1, we returns itself, yes, it's here. And that function again goes to the fib, yes, 1 plus fib and 0, yes, which is a 2 minus 2, and this returns 0, and that one returns 1. And from here we have a 1, yes, and 1 plus 1 is returns 2, and that function returns 2, and that function returns 1, and we will just add, and that one returns 3. That is our result, yes. Alright, our next problem is converting decimal number to the binary. For doing this, we have a common way, which is, for example, if I'm going to take the 12, I'm going to convert 12 to the binary, and I'm just dividing 2 every time. I'm taking the quotient here, the 6, and here I'm going to take the reminders. And I'm continuously repeat that way, which is 2. Yes, I'm going to take the 3, and this time quotient. And reminder 0, and 2, quotient is 1, and also we have 2, yes, and reminder is 1. And whenever I reach here, the quotient is 0, yes, whenever I reach 0, and I repeat, reminders will be here is 1, yes, and from here, from back to top, yes, I'm just writing like this, 1, 1, yes, and 0, and 0, which is this is our binary, which is the 12 converted to the binary, and 1100, yes, 1, 1, and 0, 0. And why we need this, yes, you may be asking why we need this. When we are solving the problems, yes, I'm always solving the firstly maths way, yeah, mathematical way, and after that I'm just doing the formula for my recursion code, yes. From here also I'm going to create a formula to my recursion code. And before creating the formula for this problem, firstly we have a formula here, and whenever I'm jumping here and here and here, yes, what do you think how it is being firstly 10 and 1 and 0 and 0? There is some formula which is happening this. Let's will write that formula. And from 1 to here 1, yes, we have formula like this: 1 multiply 10 and plus reminders 1. From this, yes, from this we will take 11. Whenever jumping here, yes, whenever we came here, we will just multiply 11 to 10 and plus 0. This is reminders. And from this, I'm going to take 110, yes. Whenever I came here, and from this, and I will just multiply 110 to the 10 plus reminders, yes. And from this, our result, which is 1, 1 and 0, 0, yes. If you look here, every time I'm multiplying 10, and yes, and every time I'm adding the reminders, yes. For this one will be our function, which is yes. From this I'm going to create a formula, and firstly for converting any given positive integer number to the binary, yes, for converting any given decimal positive integer, yes, and equal to firstly we will take the reminders, which is for taking the reminders we will gonna use modules, yes, modules, and we will add and 10 multiply to that function, which is our recursion function will be here, and which is function. Inside the function, if you look here, every time I'm dividing, yes, I'm taking the integers. For example, whenever I'm dividing that one, yes, 2 with 1.5, yes, I'm not taking the float number, I'm taking integer number. Therefore, inside the function, we just write that way, that life cycle, yes. And therefore, I'm going to write int inside. I'm dividing n by 2. I'm taking integer here. From this formula, we will be going to write our recursion code. Let's do it here, and we will write our recursion code for the converting decimal to the binary, yes. And from previous, it looks like the previous code. And firstly, we'll define a function, yes, decimal and to binary, yes. We are taking number, and inside we are we are writing the check condition with assert. N must be greater or equal to 0, and n must be integer, yes. N must be integer. If not, we just return easily error, yes, error. That error we can write inside, and the input must be positive integer, yes. I'm just skipping it. You can, if you want, you can write inside quotes, yes. And after that, in the second line, we are checking that number, if, for example, if greater than 0 in positive integer, yes. And I'm going to check to the if number, whenever we whenever we came to the 1, yes, we must return 1, because whenever 1 divided 2, yes, and the quotient will be 0, yes, we must return 1. And therefore here I'm going to return if n equal to 1, yes, and just return 1 here. Else, and we will, here I'm going to write the formula, yes. Using the formula, just return the formula, which is and n modules divided to 2, yes, and plus 10 multiplied to our function that is decimal to binary. Inside we just write int and n divided to, yes, and this is our code for converting decimal to the binary. Let's will print it and print decimal to binary, and let's will give the 12, because we know 12 what is the value, yes, 1100, and let's will write Python and recursion.py. You see it is converted correctly. Our code is working it correctly, and let's will see on the whiteboard how our function is working. All right. And we'll see how our function is working behind the scene. And let's f function, which takes 12. That f function, that is our decimal to binary function. I'm just name it as shorter, yes. And whenever we call our function, the firstly checks that input, yes, it is greater than 0, and also it is positive, yes, integer, yes. After that, and it checks to it's not equal to 1. No, it is not in this case. Yes, it go to the else, and there is we wrote a formula. Yes, we have a formula which is just divided the modules, 12 modules, and plus 10 multiplied. If we call the functions inside function with int, we divided 12 to the by 12 to 2, yes. And here I'm just keeping int. Instead, I'm immediately divided 12 to like that. And that function goes to the, and which is, it returns the 6 here, and we just take the 6 and modules and plus 10 multiply, and that functions inside we just divide also, yes, 6 divide 2. But make sure there is the int also, but I'm skipping it, yes. If I write it will be longer, therefore I'm skipping it. And that function also goes, which is it returns 3, yes, and the 3 the modules plus 10 multiply the function inside the 3 divided 2. It gives us function that is 1, yes. That function returns is 1. Whenever we write, for example, whenever our input equal to 1, we have brought, yes, the formula if, yes, and it must return 1. Here is our function returns 1, and that is multiply 1 and 10, yes, it is a 10. From here we have a 1 reminders, and just we are adding from here, yes, we receive 11 from here, and that function returns 11, and we just multiply 11 to 10, yes. From here our reminders 0, yes, that functions we are adding, and which is here our function will be and 110, yes, 110 here, and here also we have a reminders which is 0, and just multiplying to the 10 from here also, yes, and that function here, and it will be 1 1 and 0 0 and plus 0, which is our result. How our function is working behind the scene, it looks like this. I hope you understand clearly.